My name is Dino DiCarlo. I'm a professor of bioengineering at UCLA. I'm also director of the Cancer Nanotechnology program of the Johnson Comprehensive Cancer Center. I'm an inventor of the Vortex technology, which is a filterless technology to isolate cancer cells, and I'm also a founder of Vortex Biosciences. So where did this idea come from? Well, we started to explore what happens when you flow really rapidly through microchannels, so channels about the thickness of a human hair, about 10 years ago. This is a regime that others had not thought that you could even explore, and that was not even relevant. And we started to explore it, and we coined this term inertial microfluidics, and found lots of really interesting effects. So we could align, we could focus, we could order particles. We could also sculpt the fluid itself, really to achieve amazing effects. So while we're flowing fast, the cells themselves that are in these channels do not feel forces that are different than what they would feel in the bloodstream. So we also stumbled upon this vortex trapping phenomena when we were exploring how fluids behave at these high rates within microchannels. You know, any microchannel has an expansion region at its end, at its outlet, and one of my students in April of 2009, Claire Herr, observed that vortices would form in these expansion regions when she was flowing at these high rates, and that larger cancer cells would orbit in these beautiful rings, gently circulating within these vortices, while smaller cells would not get trapped at all. So once we saw that, this serendipitous observation, we realized, we needed to make use of this to isolate and concentrate these cancer cells. Isolating cancer cells from a background of tens of millions of white blood cells and billions of red blood cells, that's extremely challenging. Cancer cells are larger in size generally than these other cells, and so previous approaches have attempted to separate them out by making use of porous filters, so some old technology. There are a few problems with that. So one of the problems is that these large numbers of red and white blood cells can gunk up and clog these filters. The second is that the circulating tumor cells themselves can be relatively deformable and squeeze into these pores in the filters, and that leads to difficulty in retrieving them. Vortex technology is ideal for collecting these cancer cells without running into these challenges with filters. It collects the cells by size, but without having to have a pore or filter less than the particle size. So it makes use of fluid inertia to trap cells selectively within these microvortices based on their size. Since the inertia of the fluid is actually applying the trapping force, that allows us to flow extremely fast. The faster we flow, the more force we apply. And we can isolate these diagnostically important cells rapidly. We can then lower the flow rates, dissipate the vortices, and release these trapped cells into a clean buffer fluid. So now the process of filtering and concentrating these cancer cells becomes simple. Diluted blood is flowed through an array of these trapping reservoirs that each forms a controlled whirlpool. So larger cancer cells are stably trapped in orbit within these whirlpools, while smaller red and white blood cells, they pass through. While maintaining the vortices, we can exchange solutions to clean fluid that rinses out any remaining red and white blood cells. Then we can lower the flow rates, release the cancer cells into this clean fluid for further analysis. So Vortex technology has the potential to revolutionize how we isolate cancer cells from blood and other body fluids, achieving a truly simple liquid biopsy of a tumor. So this is extremely important as we move to an age of personalized and precision medicine, where we want to engineer drugs and immunotherapies to target each individual's tumor. Of course, to best understand how to target the tumor or multiple tumor sites if the cancer has metastasized, we need to have samples of these diagnostically important cancer cells. Traditional biopsy is costly, not possible in all cases because of the location of the tumor, and of course is painful to patients. In addition, we may miss some rare cells at metastatic sites because we can't biopsy all of these sites. This is an area where liquid biopsies can fill the void. The Vortex trapping technology elegantly applies fluid physics to address this problem with unique advantages. First, cells are gently handled to remain viable such that you get the largest amount of information to tune your treatment. The purity of these cancer cells remains high, which leads to the highest quality data without interfering blood cells. The process is also quite simple, leading to a low-cost solution with high reproducibility. So operating purely based on physical principles with well-known equations rather than difficult to scale chemistry or antibodies leads to a robust process. So the simplicity of the Vortex technology allows it to couple with downstream tests in a seamless fashion and really get deep into the biology of individual cancer cells. So what's really exciting to me about the Vortex technology is that we haven't tapped its full potential yet. So beyond the malignant cells in circulation that we can isolate, we can also isolate other large rare cells associated with other disease processes and provide diagnostically important information that we can treat patients with.